Hey, what's up guys? It's Pedro here from noobcoder.com, and in this tutorial we're going to be talking about removing the last node within our doubly linked list. Alright, so to get started, in order to remove the doubly linked list, we do have two test cases. Case 1 is what happens if the doubly linked list only has one node within it, and case 2, what happens when the doubly linked list has more than one node within it. So now let's take a look at case 1. So to get started, you can see we have our doubly linked list here, and we have our header and tail pointing to it since it's the only node within the list, and size is equal to 1. So there's two ways to go about checking to see whether our doubly linked list has only one node within it. We could check to see what header is pointing to. So I could say something like this. I could say header arrow next, which will give me here. If that is equal to null, which in this case it is, that means there is only one node within our doubly linked list. Likewise, we can also check the size data member. If the size is equal to 1, that means that there's only one node within our linked list. So what's the first step to do? Well, the first step, let's actually delete the node that header is pointing to. So if header arrow next equals null, which is what we got, delete this node. Once the node is deleted, we need to reset what header is pointing to and what tail is pointing to. And we're just going to set that to null. And the last step from here, decrement the size. Alright, so now let's move on to case 2. What happens when the doubly linked list has more than one node? Alright, so from here you can see that we have 3 nodes within our doubly linked list. And the most logical place to start would probably be the tail, since tail is always having a pointer to the last node within the list. So, in order to remove this node, we could take advantage that this is a doubly linked list, which means each node has a pointer that points to the previous node. So the first step that I want to do is update what tail is pointing to and make it point to the new last node. So who has a pointer to the new last node? Well, if I say tail arrow puev, which will give me this pointer, and this is going to point to this node. So I could just say tail is going to point to tail arrow puev, and that would advance the tail pointer to the previous node before the last node. But we're still not done from here. We still need to delete this node from our doubly linked list. But who has a pointer to this node so we could delete it? Well, tail arrow next has a pointer, so we could use that to delete this node from our doubly linked list. So once we successfully deleted the node, we have to set what tail arrow next and set it equal to null. And the reason why we need to set this equal to null is, for example, if we call the toString method, which is dependent on a loop that keeps on going until we hit null. If we don't set tail arrow next equal to null, our toString method wouldn't work, so that's why we're setting that equal to null. And the last step from here, since we successfully deleted a node from our doubly linked list, let's decrement the size. So now let's actually take a look at how we can implement this by using code. So from here, you can see we have our remove last method. It's not returning anything, so it's void, and it takes in no parameters. So let's take a look at case 1. Check if the list has one node. Now there are two ways of going about this. We could check to see whether header arrow next is equal to null, which means that there's only one node within the list, or we could check to see if size is equal to 1. So I'm just going to come down here. I'm going to say if header arrow next is equal to null, execute this code. So I'm just going to come down here and take all these comments and put it within our if statement. Alright, so from here it says delete the node, and since there's only one node within the list, we can safely assume that header is pointing to it. So I'm just going to say delete whatever header is pointing to. The next step is to set header and the tail pointer equal to null, and that's because we're basically resetting our doubly linked list. So I'm just going to say header is going to be equal to null, and tail is going to be equal to null. Then we're just going to decrement the size. So now let's move on to case 2. Check if the list has more than one node. So I'm just going to use an else if statement here. So I'm just going to say else if the header does not equal to null. Now, the reason I'm using this condition is because we haven't taken into the fact what happens if the list is empty. So by checking up here to see if there's one node, we can safely assume that if the header does not equal to null, which means there are nodes within our list, that there is more than one node within our doubly linked list. So now let's just take the comments here and let's put it within our else if statement. So the first step says advance the tail pointer to the previous node before it. So remember, tail is always pointing to the last node. So we want the node before the node that our tail pointer is pointing to. So for that, I'm just going to come down here. I'm just going to say tail is going to advance to what tail arrow prev is pointing to, which is going to point to the previous node before the last node. The next step is to delete the previous last node. Well, who has a pointer to the previous last node? Tail arrow next has a pointer to that. So I'm just going to come down here. I'm going to say delete whatever tail arrow next is pointing to. Now the next step, it says set the current last node pointer to null. And the reason we're setting that equal to null is because we need it for when we call our print method. Without setting that equal to null, our print method will create an infinite loop. And the last step from here is let's actually decrement the size. So now I'm just going to save this. Let's actually scroll down to our main method. And you can see we declare our list. We append 3 things to it. 1, 2, 3. We remove the last node. So 3 should be removed. And then we just print it onto the console. So I'm just going to bring up the terminal. I'm going to go to my desktop. I'm going to compile. And let's execute the code. And you can see that we get a printout of 1 and 2. So if you look at the code up here, we append 1, 2, 3. Since 3 is the last node within our list, we call remove last. Then we call our toString method, and we get the printout of 1 and 2, and that's because 3 has been removed from our doubly linked list. So that pretty much wraps it up for our remove last method for our doubly linked list.